When I prepared this workshop, we envisioned that it's mostly for graduate students, but I can see that most of you guys are not. So I changed the title into debugging technique. I call it debugging game. For you, you're too easy. Probably just a game. This talk is I developer. I'm the field side. The first day in the field, then mostly spend the first day to set up the instrumentation, debug what's the problem. That's it. That's the first day. If you normally what you find out, if you can collect any data in the first day, that's a bonus. So in the second day, you'll start collecting good data, and then on the third day, the student probably generally know what they are doing, and because of the budget, I'll be leaving on the third day. And this is the talk I developed on the third day. Right before I leave, I give the student to make them feel comfortable when I leave, that they'll worry about that. What happened if this break? What happened if that break? What am I going to do? So this is the talk I developed before I leave. Safety first. For most of you guys, if you're going to work in the needs equipment side, mostly the laboratory side, the operations manager will be there, so you probably don't need to worry about this. So this is most likely going to be a game for you. And always read the safety manual first. The main talk of my slide is only one slide, the secret of debugging. That's it, systematic. As long as you are systematic, you go from the source, the voltage, the cable to the sensor, and then sensor back to cable to your data acquisition system. As long as you're systematic, you'll find it. That's the only trick about debugging. But my talk is longer than that, so I put some more slides and just give you the techniques. You can do there are three most common used technique that you use when you do the debugging. First one is modulated debugging. I'll give you a sample. And also, you can check the voltage along the line or check the resistance along the line. You can also check the current along the line, but most of the civil engineering sensors are voltage-based. So you are rarely going to check the current. It's probably going to be tedious to do it that way too. So the first two methods is mostly what you're going to use. Modulated debugging. So assuming you have you're measuring the potentiometers, you got sensors, you got cable, and you got DAC systems. And then, as you can see in the table, the first one is working, the second one is not working. You just switch it. Switch the sensor, switch the cable, switch the channel, and then you'll find out that cable 2 is wrong. So replace cable 2. But this assumes that you have one thing that's working, and second thing is not working. If you only have one sensors, this is not going to help you. So you move on to the second way. It's called a check the voltage along the line. So you plug in 5 volts. This is your source, the power source. So this whole thing should be 5 volts. And then the next one, this return, this should be 0 volts. And then this one is something in between, it should be between 0 and 5 volts. Depends on the position of the tips, basically. So you know that. And if you read here 5 volts, read here 4.5 volts, this cable is not good. And to help you to check on that, actually resistance is actually an easier way to check it. You're supposed if this is 2 wires, this wire should read close to 0 ohms. Between the wires should read overload. It's high, you cannot read it with the multimeters. And the resistance of, this is some notes here that 1,000 foot long 22 gauge wire is about 16 ohms. That's just to remind you that if you calibrate your sensor in the lab with a short cable, and then you take it to the field, hook it up to a 1,000 foot cable, you're gonna get a different calibration factor. So always calibrate the way you're gonna measure it. And that comes to the second method, check the resistance along the line. Before you do this, you should disconnect the power source because the power source generally has a low resistance. So you should disconnect that one. And then this one should be close to 0 ohms. Again, the whole sensor is about 1,000 ohm, pretty straightforward. And after you're done, figure it out, remember to plug the power back on. And I got quite a lot of emergent phone call from the field that, Moon, I just checked one sensor and then suddenly everything not working anymore. Did I broke the DAC system? Generally, when the student call you in the field, they are panicked because they think they broke $100,000 worth of data acquisition system. They are panicked. Number one. Number two, they think they are not graduating. That's why they are really panicked. So, but I have been working in the field and in the lab for about 15 years already. I know that it's not that easy for you to break a DAC system. So first thing I'll tell you is that, could you mind check on if you plug it back in? And that's mostly the case. But when you are in that situation, when you are the student in that situation, if I were him, I'll be panicked too.